Hey everyone, hope you are doing well. So let's start with the question. So the question is delete and earn. Okay. So you have given an integer array nums. You want to maximize the number of points you get by performing the following operation any number of times. Okay. So the operation are, so you will pick any number and delete it to earn that number. So let's say you will delete a number from an array. So that will be added to your score. Afterward, you must delete every element equals to num I minus 1 and every element equal to nums I plus 1. Okay. So let's say you are given this array 3, 4, 2. So if you remove 4 from here, so 4 will be added to your score and you will remove the minus 1 element, all minus 1. So 4 minus 1, 3. So all 3's that are present in array, you will remove it. Similarly, 4 plus 1 is 5. So you will remove all 5 in the array. Okay. But you have to return the maximum number of points you can earn by applying the above operation some number of times. Okay. So let's see with an example. Okay. So let's take this example. 3, 4, 2. Okay. So let's say you remove this 3 element. Okay. So your score will be 3 and you will remove 3 minus 1 and 3 plus 1. All basically. So this is equal to 2 and this is equal to 4. So you will remove this, you will remove this. So your final, and you also delete this element and you add it to your score. So your array is now empty. So the final score by removing first, like by removing this element, you will got a 3. Okay, but we can't stop here. We need to do the maximum earning. So let's take this example again. And in this, let's say we remove this. Okay, so we remove 4. Okay, so in our score, you have 4. Now you will remove all element by minus 1 doing this and plus 1. So this will be your 3, this will be your 5. So you will check all threes. So you will remove all threes in the array. So you'll remove this, not any 3, and you will check for 5. So no 5 is there, so you will not remove anything. Now your score is 4 and your now array become 2 only. Okay. Now you will remove this. So your score will be added to 4 plus 2, which is 6. Okay. So now array is empty. So this is the final score and this is the maximum score I'm getting it. Okay, let's take this example again, 3, 4, 2. Now in this case, I remove this 2 element. So now my score is 2. Okay, so what I will do 2 minus 1 and 2 plus 1. So 1 and 3. I will check for 1. 1 is not present, so I will not do anything. I will check for 3. I will remove it. Okay, so now my final array become 4. I will pop out this 4. I will remove this and add it to my score. It will be 6. So, and my array is also empty. So this is also the same. So final output for this case is 6. Okay, let's take this example. Okay, so let's say you will remove this 2. So you remove this 2. So your score will become 2. And you will remove 2 minus 1, which is 1, and 2 plus 1, which is 3. So you remove 1 and you will remove 3. So 3 you will remove. So you will remove all these 3. 3. Okay, now your array become 2, 4. Okay. Again, let's say you remove 2. So your array become, your score will be 2 plus 2, which is 4. And you will check for 1 and 3. 1 and 3 are not present, so you will not do anything. Your array now become 4. Okay. Now you remove this 4 and add it to your score. So this is the final output for this. Let's see, we can remove other also. So let's take this example again, 3, 3, 3, 4. Okay. Let's say in this case, we remove 3. Okay. So our score become 3. Okay. Now we will remove 3 minus 1 and 3 plus 1. Okay, so 2 and 4. So we'll remove all 2, we remove all 4. So we'll remove 2, 2, and we'll remove 4. Okay, so now our array become 3 and 3. Okay, we'll do the same operation. We'll remove 3 and add it to our score. So 3 plus 3 is equal to 6. Okay, now we'll remove the 2 and 4. 2 and 4 are not present, so This is now our final array. We'll remove this. So this is 6 plus 3 is equal to 9. So this is the final output. Okay, so I hope you got the question. So let's see how we can approach. Okay, so for this case, as you already know, we are getting the output as 9 when we remove the 3 element. Okay, so after removing this, what we are doing, like after removing this, we remove these two and we remove these two. Okay, now we do the same work for these three. Like we don't have any -1 element in the array and we don't have any +1 element to its array. So why not convert this problem into a same subset? Let's say I call it as n, okay, and this previous will be my n-1 and this will be n+1. So why not group them into a uh, one array? Like I can call this as a count array, and what I will do, like I will create a array of this length, basically of the maximum length. So at the 3th index, what I will do, I will store the count. So at this place, I will store 3 as a value, and this will be my 3 index. So if I need to get the sum for this case, I will do 3 into 3 equal to 9. Similarly, I will group them also, like it will be having 2 here, 2 index, and this will be having a 2 as a count, and this will be having a 4, and this will be a value of 1. So if I arrange them, so this will be like my array 0, 1, 2, 3, 4. Okay. So at 2 I have 2, at 3 I have 3, at 4 I have 1 and 0. Okay. Now, if you know, one second. Okay. Now, if you solve the question like with the same previous intention, so what we will do, let's say we will take this index. Okay. We will take this, and what will be the sum or the earning, let's say sum. So at this point, I have having a sum of 2 into 2, which is 4. Okay, because I have two 2's and it's at second index. Now I have two option. Basically, either I can skip this element, okay, or either can neglect, which I have taken. Okay, so it's sort of a housing problem if you remember. So where what we are doing is we calculate the sum of adjacent, like you can't take the adjacent element and you need to give maximum some sort of. Okay, so it's related to a housing problem. Okay, so let's say you take this too. So you have only one option. You have to skip this element and you will take this. Okay, so now when you take this, it will be 4 into 1, which will become 8. Okay. Let's say you don't take this index. Now you will take this index. So when you take this index, your sum will become 9. Basically, it will be 3 into 3. And now you can't take the adjacent element because you take this element, so you have to skip this element. Okay, and for this case the maximum output is 9 only. Hope you got a little bit of intuition. It will be more clear if we write the code for this. Okay, so first of all, let's take the maximum variable. So first find out the maximum element from array. Max equal to math dot max e. So you will got the maximum element. Now we'll create our array. Okay, so this will be our array, new int max plus 1. Okay, because array index is from 0. Let's insert at particular index. So let's do like this. For int e nums, what we will do, array, like we will go to that particular element index and we'll just increment it. Okay, now let's what we will do, let's call a new function solve array, and we'll pass the array length, which will be only, or let's do it like -1. Okay, so let's solve it. Return int solve int array int n. So we have only two options. Either we will take the current element, or we will skip it. Okay, so what we will do, return so array, like whenever you take it, what you need to do, array n plus, so this will be n into, because you need to group them. Okay, array n minus 2. If you take the element, you need to skip the next element to it. Otherwise, you have two option. Second option is basically what you will do. You will just skip your current element. Okay, and whichever give the maximum result, you will take it. Math dot max. Okay, and if your you need to add base case also. So if n is less than 0, you will just return. Okay, let's run the. Okay, let's run it. So as you can see, this is accepted. Let's submit it. Like before submit it, it will fail. I will tell you. Let's submit it first. So as you can see, we are getting a time limit exceed. Time limit exceed. Why we get it? Because what we are doing is we are doing the recursion on the same problem. So let's say if you see the constraint, okay. So this is 2 into 10 to the power 4. So let's say you are at any index, let's say 100. You solve the problem for 100. Now again, by getting this n minus 1, you again got the same index. So you are solving the same problem again and again. So it will be like us. That's why it's taking so much time. Okay, so let's optimize it for more further. So let's take a memorization array. So let's call it a dp new int and give the same array. Let's fill this element with -1. -1 represent the problem is not solved for that particular index. Okay, so let's pass this. Okay, so this will be taking dp also. We'll give this dp here and we'll give this dp here also. So whenever you solve the result, you will store it in an array. So dp of n particular index, you solve it. And let's say if dp of n is not equal to -1, you solve the same problem again earlier. So this will be return of the particular index, because we don't need to solve the same problem again. Okay, so let's run the code to check whether there is any mistake. Okay, so this is arrays. Let's run it. So this is accepted. Let's submit it. So as you can see, our code is also submitted. The problem is because of we are solving the same problem again and again. Okay, and the time complexity for this is like you will do for a particular index only. So the maximum time complexity for this, if you can see the constraint, it will be 2 into 10 to the power 4. So it's a order of n time complexity, and the space where he is using 2 array, so order of n plus order of n, so it will represent order of n. Hope you like it. Thank you for watching my video.